Okay, so now let's see what happens when water molecules split apart or dissociate. So water is a stable molecule, but it does occasionally dissociate into two charged particles. So it can dissociate into a hydrogen ion or a hydroxide ion. In pure water, these ions are going to be in perfect balance, which is why water is considered neutral on the pH scale. But once we start adding certain substances like lemon juice or baking soda, that balance can shift, and that's where acids and bases come into play. So acids are substances that are going to increase the concentration of the hydrogen ions in a solution. And they can do this either by directly releasing hydrogen ions or by removing hydroxide ions, which has the same net effect. So for example, we can have hydrochloric acid, which is a strong acid found in your stomach. When that disassociates in water, it's going to release hydrogen ions and chloride ions. This results in a solution with a higher concentration of hydrogen ions and therefore a lower pH, meaning that it's more acidic. So everyday acidic substances are going to include like lemon juice, vinegar, and coffee. While they might taste sour, chemically they are all doing the same thing, which is raising or increasing the concentration of hydrogen ions in solution. So on the flip side, we have bases, and these are substances that are going to take up hydrogen ions or release hydroxide ions. So a common example is going to be sodium hydroxide, which disassociates to form sodium ions and hydroxide ions. The added hydroxide ions reduce the concentration of hydrogen ions in solution, which is going to lead to an increase or a higher pH, making the solution more basic or alkaline. So examples of basic substances are going to include milk of magnesia and ammonia. Unlike acids, which taste sour, bases often feel slippery and taste bitter. So now we can move on to the pH scale. So to quantify acidity and basicity, we use the pH scale, which is going to range from 0 to 14. It is a logarithmic scale, meaning each whole number is going to represent a tenfold difference in the hydrogen ion concentration. So if you have something with a pH below 7, that's going to indicate an acidic solution, meaning it has more hydrogen ions than it does hydroxide ions. If you have a pH above 7, that's going to indicate a basic solution, which means that you have more hydroxide ions than you do hydrogen ions. And a pH of 7 is neutral, which is where pure water is basically going to sit. So the human body is particularly sensitive to pH. So for instance, your blood has to stay within a very narrow pH range of about 7.35 to 7.45. If your blood becomes even slightly too acidic or too basic, it can actually disrupt the function of enzymes, affect the shape of your proteins, and actually affect what ions can actually cross your cell membranes. So maintaining the pH of our body fluids is really, really important. And we have something called buffers to help us resist sudden pH changes. So a buffer is just a chemical or a system, again, that's going to help resist changes in pH by either binding excess hydrogen ions or releasing them as needed. And they're really essential for maintaining homeostasis. So for example, if your body becomes too acidic because you are undergoing strenuous exercise or you're sick, a buffer system will take those extra hydrogen ions to bring the pH back to normal. If the buffering systems are overwhelmed, as in conditions like diabetes or congestive heart failure that could result in acidosis or a dangerous drop in blood pH, your buffer can also go in and bind those hydrogen ions and again bring your pH level back to normal.